is Sheikh Abdullah. I'm a research scholar from University of Malaya. My conference paper topic is enhancement of cooling using design modification on
Hello, Abdullah. Hello. I'm sorry, I guess he has an internet problem. We will be waiting for him another 1 to 2 minutes if he can join us. Otherwise, we will go for next topic. It's a young woman cost and higher education exploring the experience of a young other backward class women student. Hello, Megharani. Hello. Hi, hello, Vani. Could you start your presentation, please?
Hello.
Sheikh Abdullah is back, so we have to give him the first presentation. Yeah, hello, Abdullah. Abdullah.
Yeah, I'm so sorry.
Please.
I lost my internet connection.
It's fine. You can start again, please.
Okay. Yeah. So let's talk about the background about my topic. Since the technological advancement in industry leads to miniaturization of electronic products, as we can see that from past years we can use the desktop, but now due to the technological advancement in industry, the computer is converted into a smaller laptop and basic iPad. Date back to 1965, Gordon Moore, in the law, Moore predicted that the number of transistors per square inch is of an integrated circuit keep doubling every year, every 2 years, and decrease of. Let's talk about what the effect will happen when the electronic size will decrease. So as the electronic size will degrade, there is a possibility of heat generation, which require large thermal management. So according to BCC research on for semiconductors on 2019, they predicted that the thermal management market is likely to expand in global market with significant level of 12.4 billion to 16.3 billion by 2023. Now let's talk about literature review. As I mentioned, this literature review is basically a massive. It experimentally investigated the turbulent flow in a cubical block investigated that exposed with a cross flow and impinging jet, where they concluded that the Reynolds number ratio determined the drag produced on the jet, and deflection from its geometrical axis is due to the channel stream. Ritunes et al. As this paper is also co-authored by me. We studied that the effect of heat transfer enhancement using the multi-inlet to the heat sink, where Ritunes et al. Mitigated the temperature non-uniformity as well as the heat transfer effect to increase heat transfer. Namedi Salah numerically investigated that the heat transfer efficacy by changing the shape of the cubical block. The cubical block is like they changed the shape like chamfer shape, where they concluded that by changing the chamfer on the top of the cube, the heat transfer rate is increased from 2.7 watt to 3.5 watt. Since similar way, Arkis et al. Has made a numerical study of heat transfer. Numerical heat transfer and flow has been done by heated block with the help of jet from the top. Now, motivation and new cooling methodology need to be developed for the safe operation of electronic equipment. Much research has been done by air cooling, but the very few of them use with heat transfer enhancement technique. Due to free availability of air and simplicity of design and scope of there is a scope of thermal management. The objective of this study is to validate the numerical methodology developed with the result available in the literature, and to investigate the effect of design modification of a cubical block at two different Reynolds number. Now, we assume in our study that gravity is neglected and radiation heat transfer from the surface is also neglected. Numerical methodology takes finite volume method is used for numerical simulation using ANSYS, a pressure correction scheme, and several implicit and first order accurate scheme are implemented for space discretization. Uh, then turbulence model is used for the numerical methodology. Here are the case description. As we can see that these are the channel inlet. This is the cubical block where we are trying to cool using the jet from the top. This is the computational domain without using groups. This is our computational design with the groups. Now in the next now we would like to validate our numerical model using the experimental result of Masip et al. As we can see that there are two comparison has been made at two different Reynolds number ratio, and it can seen that a good comparison has been done with the experimental result with our numerical study. There are some certain differences. These are due to the experimental error and the limitation of turbulence flow model. Now let's talk about result and discussion. The symmetrical grooves were protrude on the top of the cube, enhance the heat transfer. Comparison of heat transfer enhancement has been done with the base design. Now it can be observed that the heat transfer rate increased by almost 26% using the groups. Now let's talk about the velocity magnitude. velocity magnitude, it can be made dimensionless using the jet velocity and in the streamwise plane. There are three different things has been seen in the velocity magnitude profile. The groove increases, here we can see that the groove increases the using the groove increases the residence time, where it will take time to transfer heat from the cubical block. And groove also reduce the flow separation on the top of the cube. And the third one is grooves can also reattachment length behind the cube and reduce significantly. Now we talk about the streamlines. As we can see, by adding the groove, there are the flow separation has been seen. As we can see that there is two wake region on the top of the cube, but by using the grooves, there is a reduction of one wake region. Now let's talk about the temperature contours are as seen in the figure. There is a presence of groove radically transfer the thermal boundary layers. Majority of transformation has occurred over the top of the cube. Influence of high temperature region is also reduced. Now, a slight modification of design been introduced to enhance the heat transfer. The increase in heat transfer rate was seen by 26% of its baseline value. This method finds the application in the cooling of electronic component like PCB. The suggested design change its work is practically feasible with manufacturing also. This future scope of the study involves determination of threshold ratio of Reynolds number. Here are some references which I have taken from the different literature. Any question?
Thank you very much for your